All right, I'd like to talk to you about how to write numbers in scientific notation. It's a convenient way sometimes to write really large or really small numbers. Let's take the number, just do 1,000. And we'll say I want to write the number 1,000 in scientific notation. Well, 1,000 is a number that's larger than 1. And we want to write it as a number that's close to the number 1. So what we're going to do is we're going to imagine we're going to place the number 1,000 in this blank space. And then we're going to start moving it either in this direction or this direction to try to make 1,000 look like the number 1. And here's the way this works. If I take the number 1,000 and I move it one space in this direction, then I have to imagine taking the decimal that exists at the end of 1,000 and moving it one space in the same direction. So now what I've done is I've taken the number 1,000, I've moved it one space to the left, and I've now written it as the number 100. And then I can take this number 100 and move it one space to the left, and if I do that, I'm going to move the decimal one space to the left as well. And so I can write this number as 1,000 as 100, moving it one space to the left, or as 10, moving it two spaces to the left. And then I'll imagine just doing this one more time. I'm going to take the number 10 and move it one space to the left, and in that case I'm going to move the decimal one space to the left. And by doing this, I've converted the number 1,000 to the number 1. Now if you look up here, you're going to notice a 10 to the 3, a 10 to the 2, and a 10 to the 1. And this tells me that in order to correctly write the number 1 as 1,000, I'm actually going to have to write it as 1.0 times 10 to the third. If I want to write the number 10 the same as 1,000, I'll write it as 10 times 10 squared. And if I want to write the number 100 the same as 1,000, I'll write it as 100 times 10 to the first. Generally speaking, when you write a number in scientific notation, you write that number in this fashion so that the number out in front is somewhere between between 1 and 10. So if I wanted to write the number 1,000 in scientific notation, I'd write it as 1.0 times 10 to the third. Let's take another number. In this case, we're going to write a really small number, 0.007. And I want to write this number in scientific notation. In this case, the number is smaller than 1, and we're going to actually move in this direction. So I'm going to imagine taking this number and placing it in this blank space, and then moving it one space in this direction. If I move this number one space in this direction, I'm also going to move the decimal one space in this direction. So I'll write this as 0. Let's see, I got to move it this way. 0.07 it looks like, right? I moved it one spot. Yep. And if I move it one space this direction, I'm going to move the decimal one space. So I'm going to write this as 0.7. And then finally, if I move it one more space, I'm going to move the decimal this way in the same direction I'm moving, and I'm going to write that as 7. So I see that I can write the original number, 0.007, in any of these ways, 0.07 times 10 to the negative 1, or I can write it as 0.7 times 10 to the negative 2, or I can write it as 7 times 10 to the negative 3. All of these numbers are equal to one another. And what they all mean is take this number and divide it by 10, and you'll get this number. Take 0.7 and divide it by 10 twice, and you'll get this number. Take 7 and divide it by 10 3 times, and you'll get this number. Okay, I want to take this number, and I want to write that number in scientific notation. It's a really small number, so we're going to end up moving our decimal in this direction. And you'll notice I have my sheet set up, so I've got the blank space for our number, and then 10 to the minus 1, 10 to the minus 2, and so forth, all the way down to 10 to the minus 9. So I'm starting here, and I'm going to move this number to this spot. So I see I can write this. I'm going to move this in one. I'm going to move the decimal one space over. So let's see, there's my decimal, 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5, and then a 4, 5, 0. And I'd write that times 10 to the minus 1 because I've moved from here to here. Let's now move this one more space. So I'm going to move the decimal one more time. So let's see, that's going to give me 1, 2, 3, 4 zeros after the decimal point. And I'm going to write that as 450 times 10 to the minus 2. Let's keep going. 1, 2, 3. If I move it one space, so there's going to be 3 zeros behind the decimal point. 450 times 10 to the negative 3. I'm going to continue this process. I'm going to stop here because usually when we're writing numbers in scientific notation, we stop when we've written the number as a number between 1 and 10. And I can see this number out in front is in between 1 and 10. 4.50 ends up being between 1 and 10. So I can say that this number here that we started with, 0.000000450, that's the same thing as 4.50 times 10 to the negative 7. Now in this particular case, I'm going to go just a little bit further. I'm actually going to move it to writing it as a number times 10 to the negative 9. So I'm going to move it one more space here. So that would give me 45 times 10 to the negative 8. And if I move it one more time again, that'll give me 450 times 10 to the negative 9. And I'm doing this for a reason. The reason why I'm doing this is when we talk about light, wavelengths of light are on the order of 10 to the minus 9 meters. Very tiny, a billionth of a meter. And you might remember we talked about the different metric prefixes. It actually turns out that the metric prefix nano, which is a little n, that relates to 10 to the minus 9. The prefix micro, which is written as a mu, that relates to 10 to the minus 6. So because a wavelength of light, actually blue light, can be written as 450 times 10 to the negative 9 meter, and because 10 to the negative 9 is the same thing as a nano, I can replace this 10 to the negative 9 with a little n, meaning a nanometer. So I can write the wavelength of blue light as 450 nanometers. So in this case, you're seeing a relationship between writing a number in scientific notation and the metric prefixes that we learned about earlier on in the course. Now in this case, we're going to write this number in scientific notation. To do this, we're going to have to remember that there exists a decimal at the end of the number. I can just stick this decimal here, and it's still the same number as it was before. Notice this is a very large number, and so this is a little different than what I wrote before. When I used a number much smaller than 1, I put the blank space on this side of the paper, and I put 10 to the minus 1, 10 to the minus 2, and so forth to the right of the number. When we're doing a very large number like this, it's much greater than 1, we do the opposite. We stick the blank space on the right side of the paper, and we write 10 to the power of 1, 10 to the first, 10 to the second, 10 to the third, and so forth in this direction, to the left of the blank space. So now I'm just going to try to write this number in scientific notation. So I'm going to move from my initial space one space to the left, so I got to move my decimal one space to the left. So instead of having 1, 2, 3, 4, 5, 6, 7, 8 zeros after the 3, I'm only going to have 7. So this number can be written as 3 with 7 zeros times 10 to the first. Let's continue the process. I'll move this number one space to the left, so I move the decimal that's here one space to the left. And in this case, I'm only going to have 6 zeros after the 3, so that's going to be 3 million. And that should be times 10 squared. So 3 million times 10 squared, which is 3 million times 100, that should be the same thing as this original number that we started with, which is 300 million. That makes sense. All right, here's my decimal. We're going to move it one more space to the left. So I move my decimal one space to the left. And now at the 10 to the 3 spot, this is going to be written as 300,000 times 10 to the third. 10 to the third, that's the same thing as 1,000. So 300 million is the same thing as 300,000 times 10 to the third. Let's continue this process until we end up with a number out here that's between 1 and 10. And now we're done. I've written the number out front as 3, which is a number in between 1 and 10. I had to move the decimal quite a few spaces. I need to write this number as 3 times 10 to the 8th to be equal to our original number, which is 300,000. This number is important because it happens to be the speed of light in a vacuum in units of meters per second. And this is given a very special symbol, C, for a constant. The speed of light in a vacuum is always constant and never changes. It's 3 times 10 to the 8 meter per second, which is the same thing as 300,000 meters per second. 300 million meters per second.